We at Qualcomm are proud to be part of the solution space in addressing this particular vexing, important problem, which is the fatality of vulnerable road users on our roadways. So with that, we have assembled a great panel of experts, which I will moderate. The idea is that we would like you to pay rapt attention, of course, ask Q&A via the pod, and we would hopefully have some time toward the end to engage in a short discussion. Adam Snyder, Director of Communications for the Government Highway Safety Association, will lay out the problem statement, and GHSA has been on the vanguard of watching out for us and taking the statistics and giving a clarion call for technology providers and others for a total safe system approach. In terms of technology providers, Jacob Harrell, Senior Principal Engineer from Harman International, will give us a Harman point of view on how to solve this problem or how to start to redress it. Shailesh Patel, my colleague at Qualcomm, will talk about a Qualcomm way of addressing this. And finally, Meena Sartipi, professor at University of Tennessee, Chattanooga, will talk about how she's marshaled with Chattanooga stakeholders a way to address this problem, put the technology together on the streets of Chattanooga. A couple of words from Qualcomm. Many of you in ITSA may know me, some of you don't, which is great that you know us from the automotive perspective. But we at Qualcomm view this as a holistic endeavor. So the idea of intelligent computing everywhere, both in our handsets and our cars and on the roadside, is very important and central to the way that we would like to approach the problem. And of course, we at Qualcomm approach the problem through this portfolio, which includes wireless connectivity, processors, and all sorts of components that underlie the technological solutions and applications that we all strive to see on our roads to start being part of the safety solution for vulnerable road users. So without much further ado, I'm going to step aside and introduce, I've already introduced, but I'll let the first speaker, Adam Snyder, take the stage.
All right, thank you, Jim. Pull everything up. Thank you. Thank you to Jim and Qualcomm and Victoria and ITS America for putting together this important discussion. I'm looking forward to it and glad to be included. Real quick note, I'm here mostly just to sort of set the stage here about what the urgency of this problem, and then let the experts talk about some of the solutions, including technology. So, a quick note about the Governor's Highway Safety Association. We represent the state and territorial highway safety offices around the country. The SHSOs, as we call them, address behavioral safety issues. We're a 501c3 based in Washington, D.C. If you do not know your state highway safety office, I recommend you find out who they are and get to know them. They work on a wide range of behavioral and traffic safety in general issues, operate a number of programs, and are a really important part of the safety debate. You can visit GHSA.org to find out who that SHSO is. But one of the things they do, for example, is communicate with the public about how technology works, vehicle technology. So what we're talking about today, SHSOs can be an important partner in the work that you all do. So about our reports, we've been putting out these pedestrian fatality reports for a number of years. We put out 2 each year. The first looks at the first 6 months of the previous year's data. The second looks at the full year of data. This is information coming directly from the SHSO. So it's really a first look at what the numbers say. I would note that these figures are slightly different than what is in FARS, the Fatality Analysis Reporting System that NHTSA operates. So there are some minor discrepancies due to the way that fatalities are counted. So just wanted to flag that in case you see any difference in the numbers if you're really diving in. But these reports really have generated a lot of media coverage and that helped raise awareness of the pedestrian safety crisis that our country faces. So I want to take a moment just before we get into the numbers, and there are a lot of numbers, I will warn you, but just to note, behind these numbers are people. I'm going to say pedestrians a lot. We're talking about people. Everyone at some point during the day is a pedestrian. We're all walking around. We're all facing this danger every day. So, these are our neighbors, our friends, our loved ones, our family members, our coworkers, and just to introduce you to 4 pedestrians here. This is me and my family, my wife, and 2 children, my son and daughter. Daughter's 6 and son is 2. We walk around every day. I log miles a day around DC, Washington, DC, between school, work, daycare, pickup, all of it. So just sort of put a face on some of the pedestrians when we're talking about numbers. We can't really lose sight of the fact that these are people, and unfortunately, sometimes these people are dying far too early, senselessly, and in preventable crashes. So what has our data found? Unfortunately, it's found that pedestrian fatalities have really been on the rise lately. We did see a very small dip in 2023. We were down to about 7,300 fatalities over the course of the year, which was a small decrease from the year before, but that is not really good news because the year before was a 40-year high. So we are still far above the pre-pandemic level. This cannot be a new normal of post-COVID life. But you can see here they've been rising just about every year during COVID until luckily this recent decrease. Zooming back a little bit more, looking back at the past 45 years or so in this chart, as I said, 2022 was the worst we had seen in 40 years. So just to set that context and sort of that while we might have had a decrease year over year in 2023, looking at what has happened since 2009 in this chart, and then what has been happening since 2020 during the pandemic, especially, this is really just unacceptable. So just give a sense of how urgent this crisis is, and how these numbers of fatalities have really increased in recent years. We sliced and diced the data a lot of different ways. One of the big things that jumped out at us was the disproportionate rise in pedestrian fatalities. You saw those charts and those steep lines with the increase, especially over the past 10 years or so. But also when you compare that to overall traffic fatalities, its pedestrian deaths are far outpacing all other traffic deaths. From 2010 to 2022, 77% increase in pedestrian deaths, 22% increase in all other traffic deaths. The numbers, those white numbers within the bar, show that this gap is widening even more in recent years. Just in the past year, pedestrian deaths went up, all other traffic deaths went down. So there's a gap, and it is getting worse. There's a number of different factors that come into play that unfortunately are making these numbers so much worse. One of those is light condition. Vast majority of pedestrian fatalities occur at night. And you can see here on the numbers on screen that has risen more in recent years. You can see the daylight pedestrian fatalities largely flat, a very small increase over the years, but really the nearly double the increase in these deaths that are occurring at dark. It's a 92% increase for nighttime fatalities, a 28% increase for daytime fatalities. I would note too that dark includes artificial lighting, street lights. So more than half of these deaths at night are happening where there's artificial lighting. So it just speaks to the importance of not only having street lighting in as many places as possible, but having that be high quality, good lighting. The presence of sidewalks. It's another critically important thing that we see evident in the data in the percentages of pedestrian fatalities. Here on screen, we're looking at 2017 year by year to 2022. And this is the percentage of pedestrian fatalities where there was no sidewalk. So we've gone from 66% or 60%, pardon me, to 66% in just a few years' time with a steady increase every year. So sidewalks, clearly very important pedestrian safety measure. They separate people from vehicle traffic, but frankly, they're missing or in poor condition in a lot of the country. And while cities, states, localities really want to try to prioritize that, it can get very costly to build and maintain sidewalks everywhere that they're needed. So while they're important, that's just one piece of the puzzle here. Another piece is vehicle size. Actually, some of you might have seen there's a new report from the Road to Zero Coalition about the importance of vehicle size and how that plays a role in pedestrian deaths and safety of everyone on the road. But you can see in the numbers on screen here the numbers of pedestrian deaths caused by trucks versus passenger cars really sort of tracked similarly for much of the decade, and beginning about in 2020 really started to have a large separation there. Unfortunately, this gap's going to continue to grow as heavier trucks, SUVs, minivans, pickup trucks, those continue to be very popular with American consumers, and smaller cars are less popular. So unfortunately, this gap's going to continue to grow, but vehicle size is one of the other key factors in this safety equation. I'd also just like to mention briefly that there are racial inequities. There is a ton of data showing these racial inequities. This is just one data point, numerous other studies pointing to this, but you can see in just 2 years' time, percentage of white people involved in pedestrian fatalities went down and percentage of Black people in pedestrian deaths went up. So unfortunately, unfortunately, I find myself saying this often. There are inequities and there are gaps, and these gaps are widening in recent years, and that is true for looking at this by race as well. There are a number of factors involved. I will just touch on this very, very quickly because I know we want to hear from the experts here. But we've seen less traffic enforcement that addresses dangerous driving behaviors that put people on foot in danger. Many of our roads are designed, unfortunately, for speed over safety. So to prioritize vehicle speed over keeping people on foot safe. Many parts of the country are lacking infrastructure, or it's in a state of bad repair. Lighting, sidewalks, crosswalks, so many other things that can help keep people safe. And as we saw also, vehicle size, one of the big factors. And what we need to do to keep people safe is we need to do everything, frankly. We need to do it all. We need to address this. We need an all-in approach for technology, which we'll talk more about. We need equitable enforcement. We need outreach and engagement. We need to get more communities involved. We need to think differently about how we design our infrastructure, and then we need to fund building more of that infrastructure. And we can't forget post-crash care. That's an important part of the safe system approach. That's how we really need to think about this problem holistically. So I know we're really focused on the technology aspect today, but that is just one part of this holistic approach. I'm really looking forward to hearing more from the experts on the panel. Appreciate being included here. You can see there's links to the GHSA pedestrian report if you want to dive in and see more of the data and numbers. And also urge you to follow us, GHSA, and me on social media. We are on LinkedIn and X, and look forward to hearing your questions and having a good conversation with everyone. Thank you.
Thank you very much, Frank. Without much further ado, because I made the intro in advance, Jacob Harrell from Harman International, you have the stage. I'd love to hear your solutions.
Yes, so as Jim mentioned, my name is Jacob Orel. I'm with Harman International. I'm very happy to share some of the work that Harman has been doing in connectivity in general, but specifically what we are doing regarding vulnerable road user safety. For those who don't know, Harman is a subsidiary of Samsung with R&D and manufacturing facilities worldwide. Harman is one of the leading provider of TCUs for the automotive industry and supporting multiple automotive OEM. In 2021, Harman acquired Savari, one of the leading provider of V2X technology, and incorporate the technology into our product line. And you'll see it in some of the demos we're going to talk about now. So as we're looking specifically in the US DOT deployment plan that was just published, which we're all welcoming as a step in the direction of mass deployment, we see that they're prioritizing the reduction of road injuries and fatalities, specifically for VRU, which mean pedestrian, two-wheelers, and micromobility in our case. To meet the safety application requirement for VRU safety, for this deployment and beyond, we will need an ecosystem that can integrate both cellular connectivity, UU, and CV2X using PC5 interface technology. Since most of the VRUs will rely on commercial cellular mobile devices interfaces. This can enhance the V2X capabilities, allowing for and accommodating for larger and more impactful data messages and transaction, and enable them to reach a larger number of participants. This overview of the ecosystem that we show here show communication via CV2X between OBUs, TCUs, and RSU, with VRU using their mobile devices over UU. The RSU forward all received and transmitted messages to the MEC wave, which also receive messages from the VRU over the cellular interface, creating a comprehensive image of the intersection and generating relevant alert for all actors, regardless of this communication modality. The MEC wave is a cloud-based SaaS system that can generate relevant contextual messages for both driver and VRU, and insight based on the vehicle and infrastructure data. And unlike a typical virtual RSU that is common in the industry, we're not handling just the communication aspect. We also include the perception algorithm and the application to generate those messages. It has two parts. One is the thin client that runs in the TCU, OBU, RSU, or the cellular device, and forward SAE formatted payload to the cloud. And the second part is the cloud-based application that analyzes vehicle and VRU data to create a digital twin for the environment visualization and generating relevant insight and alerts. This cloud application reduces the vehicle compute needs and enhance the solution scalability and integration with VRU and other vehicle that uses the UU cellular interface and not the CV2X. So we're going to talk about two demos. This demo utilizing the typical VRU use case in an urban environment. The VRU uses cell phone running the MacWave thin client application, connecting to the MacWave over a UU interface, while the vehicle can use both CV2X and UU interface. Relevant info is sent to the MacWave, which in the case of a collision detection, warns the pedestrian over a UU interface on its cell phone, and the car via the CV2X interface on a TCU or an OBU that is in the car. CV2X is also offering better latency performance, so we get an almost real-time message to the cars that is using the CV2X. Cars that are using UU are getting a situational awareness because of the concern of a longer latency, ensuring sufficient response time for the driver. We have a short video that shows part of this concept that was done in the American Center for Mobility in Detroit.
Harman Automotive continues to innovate around connected technologies, including 5G, V2X, and MEC, that have the potential to improve safety and deliver transformational mobility experiences. We are excited to be partnering with the American Center of Mobility to conduct real-world testing of these applications at their Detroit campus. The test vehicles are set up with the Harman 5G TCU, which allows for high-precision GNSS, 5G connectivity, and also a thin MacWave software client. Intersections at the track are equipped with Harman Savari Streetwave RSU, which is connected to MechWave. MechWave is deployed and running on an edge infrastructure inside an MNO facility. Our first use case is for vulnerable road users, or VRU. Here, a pedestrian is trying to cross the street in an urban environment. Due to the surrounding buildings and the vehicle parked in the street obstructing the view, an approaching driver cannot see the pedestrian who's about to cross the road. The MechWave application on the pedestrian's phone is constantly transmitting safety messages to Mech over 5G. At the same time, the vehicle V2X onboard unit is constantly broadcasting safety messages over short-range radio. The Harman Savari Streetwave RSU forwards these short-range messages to the Mech. Harman's proprietary collision core engine with MechWave constantly assesses the movement of the vehicle and pedestrian and identifies potential collision scenarios. MechWave sends out a warning message to both the pedestrian and the vehicle when a potential collision scenario is identified.
The second proof of concept we're going to talk about was in collaboration with Intel, using cameras as a sensor connecting to the Intel Smart RSU, running on an Advantech hardware platform and sending messages via the V2X hub from Saxton Labs. The Intel Smart RSU is designed to enhance transportation safety and efficiency. It leverages AI algorithm to analyze data coming from vehicle and other sensors and use Intel software, including OpenVINO, DL Streamer, Synscape, and Getty to help speed up time to market. The Smart RSU can process data from multiple cameras, generating insights into the situation in real time. The system we are presenting here uses a camera to monitor the intersection and detect potential VRU to vehicle collision. Vehicle data can come from over CV2X and be forwarded from the RSU to the Smart RSU, or can be detected using a camera and the AI perception. Detected collision risk in the Smart RSU triggers a T message through the V2X hub to the TCU OBU in the vehicle, ensuring real-time communication and response, in addition to sending warning via the RSU to the MechWave. The MechWave can also send situational awareness for vehicle using the UU interface. Those demos showcase some of the Harman MechWave solution capabilities and flexibility, working in cooperation with infrastructure system to enhance transportation safety and efficiency. It integrates multiple communication methods to analyze data and generate warning and situational awareness messages per channel capability. Reducing injury and fatality is a goal for all of us and requires the industry government collaboration, and as it comes to standard and interoperability. So as the slide here says, let's define the future together. Thank you.
Thank you very much, Jacob, for the nice exposition of the Harman approaches, plural. As we know, it takes many approaches. I'm going to segue from this, and please, folks, put your questions. Some of them are being answered in the Q&A box. But to my colleague, Shailesh Patel, to describe a Qualcomm perspective and point of view on addressing this dire problem.
Thanks, Tim. So can you see what I'm sharing?
Yes.
Okay, great. Thanks for the opportunity to ITS America and to Jim for inviting me. My name is Shailesh Patel. I'm Senior Director of Technology at Qualcomm, and I lead the automotive connectivity research within Qualcomm. So today I'm going to talk about the cloud-based VRU safety. So, and I guess the emphasis is on the cloud aspect here. So typically we have, from Qualcomm perspective, we have sort of worked on the CV2X, SiteLink, PC5 aspect a lot, and like my team wrote that. design as well. But for VRUs, we realized that, given like the challenges and given the technology, maybe it's better to go the cloud route. So focus today is on the cloud aspect. Yeah, so this is the agenda. We have introduction, system design challenges, and then we have a large scale VRU demo that I'm going to show a video of basically. Um, so the motivation, as was mentioned, that pedestrian fatalities are close to 40-year high. So it's good to know that there's some drop which happened last year in 2023 compared to 2022, as the speaker earlier mentioned. And the interesting thing is that, well, I guess is that, these things are happening even though vehicles do have these technologies which were not there, like automatic emergency braking. And we still see, the pedestrians fatalities at a level that is not acceptable, basically, right? So even though more technology is being added, we don't see the trends in the right direction as we would like it to be, basically. And the question sort of we were wondering is that given that these technologies are already there, like automatic emergency braking, can cloud-based tracking and informational warning help, basically? So when we started this work, we sort of were thinking about this, that, first question which came to our mind was that, we do have these technologies like automatic emergency braking. Why should we use the cloud, basically? And that's sort of an important question that we thought about for some time before sort of proceeding on this work, basically. So maybe one thing to clarify here is that unlike automatic emergency braking, which happens which is something which is what we call as active safety, in the sense that the vehicle takes a decision to brake in an emergency manner, cloud-based solutions won't do that. They will be focused on what is known as informational safety, or what we want to call as informational warning, where a vehicle is aware, or the driver becomes aware of a pedestrian that is close by, without getting into without taking any action. So it's dependent on the driver to still take the action. The job of this approach is to sort of let the driver be aware more about the surroundings, similar to the video that was shown by our Harman colleague, basically. So keeping this in mind, we sort of looked at some statistics, and we looked at, since we are sort of, located in San Diego, so it was a little bit natural for us to just look at the San Diego data. And we looked at all the VRU accidents. So these are not fatalities, but these are the accidents. And it was an analysis done by my team. Jim was also involved in these discussions. And we sort of looked at all the violations which are there. Some of them are listed, not all of them are listed here in San Diego. And we said, okay, which ones do we think can we classify as can benefit from a cloud-based warning? So things like, especially accidents which happen at crosswalks, or which happen because there's not enough lighting, we think do not need like a strong positioning accuracy, and therefore they can actually benefit from a cloud-based warning. Anything that requires a fine positioning accuracy, where you're taking that, probably won't benefit from a cloud-based warning. And our analysis seems to suggest that we can take the data that is there, and from that we can it seems to suggest like around 2/3 of the accidents require only coarse positioning, and that would have helped. So just prior warning would have helped. And so we think that there is a place for cloud-based VRU safety, basically. So the point is this, that we see a place for, despite emergency braking being more and more prominent in vehicles, there is a place for informational safety warnings, basically. So with that, we sort of said, okay, let's design the system. This is sort of like a sketch of the design that we have. We have a VRU, but just like as Harman colleague mentioned, that they have smartphones with an app. I mean, it doesn't need to be a Qualcomm app. We'll just expose some APIs. It could be some other apps which sort of use these APIs, where they send position, velocity, and accuracy estimates to a cloud. And we have a car-to-cloud solution which can sort of use this basically. So it can um, uh, keep track of the VRU data. So as the VRUs keep on reporting this information in a continuous manner to the cloud, similarly, vehicles can also report this information in a continuous manner to the cloud. And then the cloud can sort of take this data and figure out which pedestrians are close to which vehicle, and alert the vehicle about this, basically saying that, okay, saying that, in your neighborhood, these are the pedestrians that are close by. And it's up to the auto EM on how to alert, basically, right? Sometimes it may not show this information to the driver because it's just too much information. Sometimes if it's close enough, then it may decide to show the driver, basically. And we sort of thought about all the technical challenges with such an approach. So like end-to-end latency, how do we scale with the number of pedestrians and vehicles? What is the positioning accuracy which is needed? And our rough thinking is that, even with reasonable accuracy, there is a value for this technology. And even with the current capabilities that are there in the cloud and in the smartphone positioning and the vehicle positioning and overall latency of the network, we still think that it's good to cover a large percentage of the cases, and we can have a viable system today, basically. So given that, let me just go to our demo we had shown at MWC. So this is like a large-scale VRU demo where we have a pedestrian, which is shown here, ego vehicle. And it will encounter like 10 VRUs as it drives around, basically, and we'll show how the warning will be shown. On the left-hand side is like how the warning is sort of shown to the driver, basically. So this is like the screen in the navigation screen in the driver's cockpit, and what kind of warning it will see, basically. So let me just start the video. So we have the car driving, and you can see from the drone view that there are 3 pedestrians who are reporting their information to the cloud, and that gets reported to the vehicle, and a warning is generated, basically. And you can see that, I'm just pausing here, that all the 3 pedestrians are shown on the screen of the driver, and the warnings are also generated. Maybe one thing to I just want to mention here is that right now we're just taking, we don't do any filtering of the position data from the pedestrians. We just take the data as it is, and we are able to generate these warnings, and it works fairly well, basically. The point being that there's no additional filtering needed to achieve these kind of, to get some reasonable warning, basically. And we see that the pedestrians, as they're walking, their information is getting updated on the screen directly. And, of course, the driver is aware and can hold on until the pedestrians have passed on. Now the vehicle makes the turn, and you can see on some of the pedestrians, the warning has gone away because, they're far away and does not match. As the vehicle makes the turn, there's a bicyclist which is far ahead, which is not visible even in the drone, but the driver is already aware of the bicyclists and the pedestrians ahead. So, the driver is ready. And then we see this bicyclist come up in view of the vehicle, and now the vehicle driver can see it. And as it approaches the intersection, it realizes that there are multiple pedestrians there, and it's already aware of them. Once it's at the intersection, it can see all the pedestrians, basically. And again, there are multiple pedestrians, so all of them are being shown simultaneously. There's no filtering of the positioning data, as I mentioned, and the pedestrians are holding the phones in different ways. Like some of them are swinging them, some of them are holding the phone in a reading position. Some of them have the phone in a pocket, basically. So a similar thing happens again at another intersection, the next intersection that we are going to show, where the bicyclists are also going towards. And then again, there are pedestrians which show up on the screen for the driver, but they're not even visible on the drone, and they'll become visible soon, basically, as you approach the intersection. So the point being that what we're trying to say is that, even with the current off-the-shelf smartphones, with the current technology and current 5G networks, we can achieve performance. We can sort of build a network which can give you a benefit of safety today, basically. So that's the takeaway for us, basically. Thank you.
Thank you, Shailesh, and thank you for showing a Qualcomm campus where I'm often a pedestrian. It does more than just good for me, though, and laying out the technology in a clear way. Thank you. So with that, I introduce our last speaker before we tee up some Q&A. I noticed there's some nice Q&A going on in the Q&A box, so please keep on entering the questions, which is Professor Mina Sartipi of University of Tennessee, Chattanooga, and a denizen of Chattanooga who's been doing a lot of great things in that city. And Mina's going to talk a little bit about how she puts things together to address the VRU safety problem in this particular community.
Thanks, Jim. Thanks, Qualcomm and ITS America for inviting me to this webinar. I will be, as Jim mentioned, I'm going to be talking a little bit about actually deploying these technologies. And there were two things that I would talk a little bit about efficiency, and how is it related to VRU safety, and also about this how we're making the street safer. I do want to mention a lot of these projects. I'm going to be talking about 2 or 3 depending on the time. They're all work in progress. So some of the results that we already have, I'll be talking about it. So in terms of deploying technology, we have deployed one corridor in Chattanooga back in 2019. You see with the dark blue dots that it has a variety of sensors, LiDAR camera, air quality and audio sensors, as well as in terms of connectivity, we have CV2X as well as the SRC, Wi-Fi, and different wireless communication capability. And we also have edge computer at these intersections. We are in the process of adding the highway to this testbed or to these smart poles, which are the lighter blue. And also we have city and university with our partners, we have received the funding to expand it to the shaded area, which would be about 120 some intersections that would be all equipped. So data that from these intersections would be received, as you can see, air quality, we receive data from all traffic controllers, the SPAT data, SPM data. We do a lot of video analytics and 3D perceptions. One of the project is really how can we accurately detect and classify these VRUs in any intersection in terms of different lighting, different weather, and different geometry for the roads and intersections. How can we actually accurately detect them and being able to track them and find their trajectory, and then we will know that, okay, are they in danger or is there a risk, assess that risk, and then being able to use V2X, being able to send these messages to them. And we also, in addition to that, for the vehicles, we also calculate the volume. And the frequency and the data type, it's there. And you can see that for one corridor, we collect about 10 million events message a day. And in terms of processing, we do a hybrid version. We have edge computers at each intersection so that we can process the data there. We have all of these poles are connected to fiber. So through the fiber data come to our data center. We do on-premise, and then we also use cloud for these applications. And one of the things about this testbed, which we call it testbed as a service, is there is a capability for others to be able to access it. So there is a SDK that historical data and limited on real-time data can be accessed by others. And one thing is that privacy is a major concern for us, that we respect that. So no video is being recorded. So in terms of the video data is everything that we process, the events out of those would be accessible. So as I mentioned, we collect all these data, and there are cases that we go out. So these are all our people from our team. I know it's probably very small to see, but we take scooters, wheelchairs, bikes, and such. We go out and we collect this data. And what you see on the top is the same scene, different day, probably with the that you will also see with the LiDAR. So that is where we do a lot of sensor fusion and this is an ongoing project with FHWA to improve the detection and trajectory prediction of all the users from scooters, cyclists to vehicles, and if it's a truck or not, and you can see that. So we collect all of those. We process everything in real time. We collect all that, and the data that we collect from connected vehicles, we have limited sources of that as well. And based on that, we have built different models of this. This is a simple model that we have built in this VISIM. And I will give credit to our partners in a coming up the slide that they have helped us with it. So you can see that this is the corridor. This is actually the intersection that I was showing the data collection a second ago. And we built this for all of the intersections so that we will be able to know the number of vehicles, the status of the light that they get there and such. But we also have it in a 3D in a more granular level, and in this case, what you see here is actually pedestrian also involved. So and the colors, the model of the vehicles, those are all random, but everything else comes from the real world. That the number of pedestrian, how long did they wait to cross the street, or how long did they have to wait to cross, or how long did it take them to cross the street? So all of those are factors that we need to know, or the left turns that sometimes that the near misses happen actually then. So these are all the ways for us to collect that data. So one of the applications that we have been looking with our partners that you see, in addition to the university, University of Tennessee Chattanooga, we had Pittsburgh, Georgia Tech, and Oak Ridge, in the city of Chattanooga, was to collect all of that data. In reality, is we're looking at optimization traffic control. But one of the factors to that, as you can see in the right bubble, is also multimodal priority. So we want to see that about the pedestrian. So if the pedestrian are detected, how can we service them? Or if we can have the transit signal priority, any of those different priorities for different modes that is given to the system, how are we going to be addressing that at the same time, making sure that the traffic is flow more efficient and it's more both in terms of energy efficiency and at the same time in terms of the safety for all road users. So that is the factor that we wanted to see how we will be able to achieve that. So I'm not going to go to the details of this slide, but this is one of the approaches that we had using reinforcement learning. And in this case, you see that we have been basically in I'm just going to show you some of the results that EcoPI is basically representing the excessive amount of energy that was used. We're reducing it by 21%, or the number of stop delays by 40%. And this shows the case that compare them side by side. What you see on the left is actuated, which is what basically existed on the corridor, and the one on the right is our algorithm. Same traffic is getting to each intersection, but we see that this algorithm can actually adapt to the system, to the data in real time, and we'll be able to make the traffic flow more efficiently. Another application is we have this also mobile unit that consisted of LiDAR, camera, and thermal camera. And this is for us to be able to collect data at mid-blocks or cases like rural areas that we don't have necessarily access to these poles that we have been collecting data so far. And what we collect from this setup is the counts on every moving object on the area that we were monitoring, what was the number of near misses, and we do traffic studies, and we have some performance measure. And this this mobile unit also has solar panels, so it can be left somewhere for up to 2 weeks. It has edge computing, and also it has the connectivity. It has the V2X. So if it is connected, we can process the data in real time and we can have access to it. Or in one case, we actually left it somewhere. We did the data, collect the data, and then we brought it back and then we process it. But one of the very recent studies that we used for this is on Macaulay Avenue, which is next to campus. That's for one of the main entrances to campus, the picture that you see there. And one of the things there that we were tasked for was they were worrying that there was a lot of students, because one side of the street are the dorms and parking, and the other side is the campus. So we wanted the campus police wanted us to study the safety of the pedestrian there, because there was this is in the mid block, which the two intersections to the side are far apart. And they wanted to understand that what was the safety of the street there. And this is what you see here. So this is where we had the mobile unit located, and these are the two intersections. And these are the parking, and what you don't see here that is cut off, these are our dorm, some of the dorms on the campus. So what you see here is this is only from 2 days data, 518 mid-block crossing, And then in terms of the near misses, if it was for 5 second pit, it was 207 near misses, and for 2 second it was 33 near misses. So this is what we have communicated this back with both with the campus police and the city police department, and they are in the process of actually adding more beacon, some lighting, and then like also potentially adding crosswalk. We will see that what is really needed to happen. So this mobile, and then we are going to be using it in other places as well to be able to understand this. So up to this point, it was really understanding the risk, and then it would get to the next steps would be what we heard both from Harman and also Qualcomm about how do we actually do this communication, which brings me to the last project that I wanted to talk about. And this is a smart funded project. It's a recently funded project, which the partners are listed here. And this is with project that we are actually, like up to this point, we have done quite a bit of analyzing the data from the infrastructure. And this project is going to be actually enabling us to communicate this back to all the road users. And how are we going to be doing it both at mid blocks and also at intersections? So the goal for this would be we were retrofitting vehicles, private vehicles, school buses, and transit and city fleet with different technologies to be able to actually provide that communication back to the road users. And this is going to be deployed in two of the major corridors. One is health corridor, because of all major hospitals in the city are actually on that corridor. The last thing I wanted, just basically as an overview, and you can see that CARTA is our transit agency here in town, and Hamilton County school buses, that's what we have them, and also 911, because we're going to be doing preemption. So the goal is basically plan to implement this and proof of the concept of this V2X technology, that we will be seeing that if we have the transit signal priority, preemption, and pedestrian priority, but what if there is a conflict? How are we going to be answering that? So hopefully in a year or less, we will have some results that we can be showing in terms of the progress on this project. Thank you.
Thank you, Mina. I invite the panelists, each of whom gave an outstanding segment of something that is a holistic story with regard to technology to this dialogue. And there is a dialogue ongoing right now in the Q&A. And I'm going to start reading some of them off because we have 12 minutes or so. So those of you in the audience, please feel free to type them in. We'll do our level best to get to them either in real time or post facto. But Adam, you've done a great job of answering several online already. But just generally, could you give us the gist of the answer? And one question which you hadn't answered was about what GHSA is doing regard to data for pedestrians in rural areas. So if you can just in one fell swoop kind of address those points, that would be great.
Yes, thank you, and welcome. Any other questions, please feel free. Anyone who's not able to put things in the chat, feel free to follow up with me afterwards. I'll address on the rural issue. Certainly very important, and that's where some of the unique safety challenges really sort of stand out. Specifically, I had talked about the importance of lighting and sidewalks in pedestrian safety. That is exceedingly expensive per person in a rural area compared to a city. So that's one of the specific challenges. Our data was really at a state and national level. So the numbers I had spoken about were national. We do break some of the data out by state. A number of the states do have much more localized data, though. So in terms of the sort of rural urban split, we don't have that in our data, but it's certainly there, an important consideration, especially when you think about some of the unique aspects of addressing it in the rural area. And that's where I think technology can be a huge help. So
Adam, also, and I missed this, but this segues nicely into what you just said. Have you considered or have you been in discussions about poorly aimed vehicle headlights? Obviously, that would be pertinent in all areas, but particularly rural areas.
Yes, I'm not too familiar with the ins and outs of that debate, but clearly vehicle design and lighting are important, and so I'm not sure exactly where they're going with that one, but I can certainly see that being a concern.
Thank you. I'm going to move on to some other questions. Jacob, there's a whole span of questions aimed at your presentation. Some of them actually could apply to both what Harman, you are doing and what Shailesh is doing with Qualcomm, but this one is could be either, but let me just pose it for you for now. How accurate is location data of VRU, specifically in dense urban contexts? Would there be false alarms if GPS location is off?
Yeah, so GPS is a painful issue, especially with VRU. When you talk about cell phone capabilities, a lot of them are still the single band GPS, and also there is no control of how the user is going to hold the cell phone. It could be somewhere in his back pocket or in his bag. So this definitely can be a problem. But I think we need to look at the holistic solution. This is why we actually showed two demos here, one that is relying on the GPS on the VRU system and one that relies on camera. So in places where you have open skies and good GPS, and you can kind of estimate it by some of the parameters on the GPS, you can use the GPS from the cell phone. And in some cases, you'll prefer to use a camera, but this will require additional infrastructure and additional cost from the DOT or IOO that is managing this intersection. So I think that there is different approaches here. GPS on cell phones are getting better. We see now even triple band GPSs on some of the cell phone, but this is work that we're still doing. And this is even before we get into jamming and spoofing, which is a whole different kind of form that when it comes to GPS.
Thank you, Jay. Shailesh, GPS figures prominently in the solution you presented. Do you have a take on this as well?
Yeah, thanks, Jim. So yeah, so GPS, as Jacob mentioned, is an issue. So that's why, but I guess we can sort of address a large substantial part of it by saying that these warnings are informational warnings. So just knowing so if I'm driving at late night and there's no visibility, just knowing that there's a pedestrian who's walking by, even though I don't see it, and I don't know exactly the location of that pedestrian, is quite beneficial. So I think the point that I'm trying to make is that if we focus on informational safety aspects rather than saying that you need to have exact location and act accordingly, there's still a lot of benefit basically. So once you go in that direction, then the value of highly accurate GPS location is lower basically. It's of course better always to have better location, but you can get a lot of things done without having the best location basically.
Thank you, Shailesh.
That's what we've shown in our demo basically.
I'm going to move on to the next two questions, which I believe are aimed at Jacob. And I want to point out that Shailesh, just to confirm for everyone, the concept that and the solution that you presented it provides an alert to the driver, not necessarily to the pedestrian or bike rider.
Yeah. So the focus is on the driver, basically.
Right. So it's a different concept, but Jacob, your concept alerted the pedestrian. So the pair of questions are: does the pedestrian have to be looking at their phone?
Yeah.
And are users of cell phones educated about the dangers of distracted warning?
Yeah. So as I said, those are proof of concept. So this is definitely not the final product, and we need to think on the human aspect of the solution and how this is going to materialize at the end and how people are going to use it, and definitely take care of cases like distracted driving, or for distracted pedestrian walking around and just walking into the street without paying attention, looking at the phone. So definitely the final solution should not be people walking around just staring at the phone waiting for warning. It should be some other mechanism, maybe an audible or vibration. So definitely we need to look for what would be the optimal solution that we're going to deploy at the end. But at this point, those are just proof of concepts.
Wonderful. I'm going to skip a few because I see Mina gave a presentation last. So if I go chronologically, we'll never get to the questions that were addressed to her. But here's an interesting one. Is the MMITSS the software being used at the edge for multimodal priority request management? So very specialized question.
Yes, and the short answer to it is yes. It's we're not only using, so it's multimodal intelligent. I think it's ITS actually. The rest of it, that is like basically it's handling the receiving multiple priority. So the short answer for one of our projects, yes, we are looking into that, but we are also adding some other concepts that I was talking about in terms of priority to pedestrian and some other modes as well.
And Adam, I'm going to address the next question to you because GHSA would be in the know and you refer to databases, but is there a standardized national crash database for unfatal crashes that researchers can use for their studies?
Yes, I believe FARS, the system that's I know it's called the Fatality Analysis Reporting System, but I believe they also track some of the injury statistics. That's our report focused on fatalities, which unfortunately there are far too many of those. But the NHTSA, the National Highway Traffic Safety Administration, does maintain some data. I'm not sure to what extent and how sort of publicly accessible it is for studies, but that would be my recommendation.
Wonderful. We're running out of time and we have a ton of questions, but one is particularly interesting and could be addressed perhaps by each of the panelists in a round robin or rapid fire sequence. So are there concerns with this technology in regard to equity? For example, only those who can afford a new vehicle or a connected display player are able to see safety messages. I'm going to extend that example to see maybe a nice smartphone. Would love to hear any discussion from experts on this. So quick take. We'll start with you, Adam, since your screen is enlarged, since you just, at least on my display, since you just answered the last question. Do you have a take on technology and equity with regard to VRU safety?
I really appreciate that being pointed out. We cannot lose sight of that. GHSA, we've done a lot of work to support equity, and I think it's a key consideration, especially when we think about the cost of these technologies and who they are deployed to. There's a lot of work going on to sort of reach out and involve underserved and underrepresented communities in safety programs. And this is a good reminder we need to extend that work to the technology side of things as well.
Thank you. Mina, do you have a way to address this question?
I think as part of the work that we would be doing with you all at Qualcomm, I think we're going to be looking at less expensive solutions for non-connected vehicles. So I think we might have some better answers, but that is a very important question. And that's something that we do look into it to see that how all road users, connected and non-connected, can be benefiting from this technology. So it is part of the solution that we're looking into.
Thank you. Jacob.
I think there's a problem always with new technologies when it comes to equity, because new technology will go usually into the new devices that are usually more expensive and not available for everybody. But we need to see what type of backward compatibility we can achieve here. So for instance, with cell phone, if we can run the application even on older generation with limited capability, but still give some benefit to the user, I think this is one approach that we can look into.
Right. And Shailesh, is there something that you would like to add to this discussion?
Yeah, I think it's an interesting question. I mean, and it's something that should be addressed, right? But maybe like if there's an infrastructure angle, then everybody in the community benefits from it. It's not just so the equity comes in that way. Another interesting thing maybe to point out is that, the pedestrians that get saved even with an expensive connected car may or may not be like rich or have that equity issue, right? So any benefit is useful benefit to start off with, in my view, basically.
Right. Thank you. I would like to end by thanking the panelists and particularly thanking this audience, which was large and asked diverse and important questions. The end note is really, I'm going to go back to the title of this webinar, Connectivity Solutions for Vulnerable Road Users. Let's have safer roads. So let's not make it an abstract thing. Let's put this technology and a holistic safe systems approach together on our roads and start saving lives of pedestrians. With that, I conclude the webinar and thank you all again and again very much.
Thank you.